Okay, hi, Assalamualaikum semua and good afternoon. Okay, I am Dr. Rohana. These are the contents for today's lesson. Okay, chapter 1. Chapter 1 is vector calculus. So you must know what is vector. Look at, before that, look at the definition of scalar. We have scalar and vector. So scalar is the quantity that has magnitude. Magnitude is like size or amount only. Yeah? So for example, time, temperature, length. Okay? Length is 10 cm. Okay? It has magnitude only. Magnitude is how much. So example of scalar quantity is distance, speed, time, mass, temperature, and pressure. Meanwhile, vector. Okay, vector is a quantity that have both magnitude and direction. Okay, magnitude and direction. For example, we have here, this is velocity. Velocity has direction. Okay, force. Okay, you pull something towards some direction. Acceleration, and so on. Example of vector is displacement, velocity, acceleration, force, weight. Okay, position. Look at the first figure here. Speed and velocity. Okay, speed is scalar. Okay, scalar. Meanwhile, velocity is vector because velocity has direction. We can have negative velocity here. This is the positive velocity. Okay, what about mass and weight? Kalau you tengok macam sama kan, but they are different. Mass is amount of matter. So we have, for example, 150 kilogram. But weight is the attraction of amount of matter to the earth. Okay, to the earth. So weight is a vector. Okay, and this figure. What the distance and displacement? Scalar. Okay, for example, 5 kilometer. Okay, but displacement is vector because we have some direction, okay, or position. You start here and you end here. So displacement is a vector. So this is a vector. We represent vector as like this. Okay, this is the tail, or you can write it as initial point. And head or terminal point. Terminal or end point. Okay, so a vector has magnitude. This is the magnitude. The length of the vector is magnitude, and we have direction. Okay, this is the velocity of flow towards wall. The flow, the velocity of flow towards this wall, and we have velocity here. That's why we learn about vectors. Okay, I want to study about flow and some more. Alright, vector notation. How we write vector? Okay, you can write it as U as a letter bold. Okay, or we put arrow on top of the letter, or we can write it like this or like this. Okay. Alright, vector in two-dimensional. Okay, this is a vector from origin to a point B. So mathematically, we can write a vector like this. Or you can write it as AB arrow. So this vector is, look at the component of x. This is x, this is y. 6. So we have, this is how we write vector. Okay, 6 and this one is 6. So 6, 6. Or you can write it in the form of array. 6, 6. Okay, next we have vector in 3-dimensional. Okay, we have x component. We call it as component of vector. Okay. So in 3-dimensional, we have 3 components of vector: x, y, and z. Okay, this part I want to show you that we have negative vector. It's a vector from E to F. It is vector W. Then the opposite is negative W. Okay, the pink one. And below, I want to show you that vector can be anywhere. Alright, this is the same vector actually. This one and this one is same. Okay, magnitude is the length of vector. And this is the notation. This is how you write magnitude. You and you like this. Okay, if we have two vectors, vector u and also vector v, the magnitude of uv is defined as like this: v1 minus u1. Okay, we minus the same component. Okay, and then you square. Okay, plus v2 minus u2 and square, v3 minus u3 square. Okay. If the vector start from origin, then we have this formula. Okay, look at example 1. Given given vector A and also vector B, find the magnitude of A, B, and also AB. So we want to find magnitude of A. So A equal to square the component, plus negative 3 square plus 4 square, and then you square root. You will get square root 29. So the length of vector A is square root 29. Then calculate for vector B, magnitude of vector B. Then okay. So magnitude of B is, look at here, 1 square plus 5 square plus 0 square. Equal to 1 plus 25 equal to 26 square. Okay, and last one, magnitude of AB. So we have point A to point B. Okay, vector A from vector B, and we want to find the vector, the magnitude. So minus the same component. 1 minus 2 square plus 5 minus 3 square plus 2, 1. Okay, 0 minus 4 square. And you will get square root 81 to 9. Okay. So the length from vector A to vector B equal to 9. Okay, the unit vector of U is given by V hat. V hat equal to the vector of U divided by its magnitude. And magnitude of unit vector equal to 1. Okay. And we have vector U here. Unit vector of U is here, where the magnitude is 1. So you can denote it as vector V hat. Unit vector is vector that point to the same direction. Okay. This is the same direction like vector U, but it has magnitude 1. Okay. This is how we calculate unit vector of U. Okay. Vector U divided by its magnitude. Okay. This is the important part of unit vector. Okay. When you see vector, okay, we always represent the vector like this in the form of I, J, and K. I, J, and K is unit vector. We can write this vector as this one in the form of I and also J. The magnitude of unit vector I, J, K is 1. Okay, here. I, the magnitude is 1. So the component of X of this U consists of 3I. Because this one is 1I, and proceed 2I, and then 3I. So that's why we write 3I. Same with J. Okay, because the nature of unit vector is 1. So we have 1, 2, 3. So U equal to 3I plus 3J. In 3-dimensional, we have extra K. U, J, and K. K is the unit vector in the Z direction. Okay, look at example 2. Define unit vector of A. So A hat. If you want to find unit vector, put hat equal to this A divided by its magnitude. To find magnitude of A. -5 square plus -2 square plus 3 square. And we get 38. So unit vector of A equal to 5, 2, 3 divided by, this is the unit vector. Unit vector of A. Magnitude of this vector, this is vector, right, is 1. You can try it. Okay, let's proceed to operations on vector. Okay, we have addition, we have subtraction, we have scalar multiplication, and we have vector product. Okay, look at addition of vectors. If we have this vector A pointed up, and this one is vector B. If we want to find addition of A and B, A plus B, A plus B, okay, start from here, A, B. Okay, we want to find, okay, this is the vector of A plus B. This one is A plus B. Okay, to calculate A plus B, just plus the component. X component with X, y with y, z with z. So look at this example. We have u equal to 1, 2, 3 and v equal to 2, 4, 6. Okay, u plus v equal to 1 plus 2, 2 plus 4 and 3 plus 6. Okay, we plus the same component. Then we will get 3, 6, 9. Subtraction of vectors. Okay, if b here, b pointed downward, and we can also have negative b, macam tunjuk tadi lah. Negative b is the opposite. So a minus b is actually a plus minus b. So that's why, okay, to do the calculation, to draw the figure, this is a and then negative b here. A, b here, negative b. So this one is the vector of a minus b. Alright, to calculate a minus b, so just minus the same component. 1 minus 2. Negative 1, negative 2 and negative 3. Scalar multiplication. Okay, if k is any scalar, scalar is a number and a is the vector, then we can multiply k with vector a. Okay, just multiply all the component with k. Okay, if we have, okay, we want to find 2u. 2u equal to 2, 1, 2, 2, and 2, 3. So, look at how I write the vector. Okay, tengok macam ni. This one is for vector. 4 and 6. Alright. We have vector product. We have dot product and cross product. When you do dot product, you will get the answer is in the form of scalar number. But if you do cross product, the final answer will be in the form of vector. This is how you check your answer. Okay. Okay. Dot product. Let's say we have two vectors, u and v. Okay. Dot product of u and v is given by this one. So dot. Dot senang je nak tulis u dot v. Okay. So to get dot product, u1 multiply with v1. And then you plus, okay, plus all the same component. U1, V1, then U2 plus U2, V2, then plus U3, V3. And last one, you will get scalar, you will get number. Okay, let's say we want to find U dot V. Negative 5, 1, 3, dot 2, 4, 6. Okay, multiply the same component. Negative 5, 2, plus 1, 4, plus 3, 6, 12. Okay. So remember, when you do dot product, you will get the final answer will be number, scalar. Okay, these are properties of dot product. Okay, dot product is cumulative, which means u dot v equal to V dot U. Yeah, look at this example. Okay, let's say we have A dot B. We want to find A dot B. 5 multiply with 9 is plus negative 8 multiply with 2. We get negative 11. Okay. So you multiply the same component. Okay, if you want to find B dot A, 5 plus 2 negative 8. You'll get the same answer. Okay. Dot product is cumulative. And okay, properties number 2. Dot product is associative, where you can expand. When you see this kind of question, you have dot and also plus. So you must expand first. You expand. You multiply u dot v plus u dot w. Okay. You can look at the example. Okay. The third property, when you dot with the same vector, okay, you will get, okay, the answer is its magnitude square. If we have, let's say, v multiply with v, so we get magnitude of v, vector v. So let's say for this example, u dot v equal to 14. Okay, after I do the multiplication, I get 14. And try to calculate the magnitude. So the magnitude of u equal to square root 14. Okay, and then after you square, you will get 14. So that's why when you dot the same vector, you will get its magnitude square. Okay, for dot product, you can find the angle between the vectors. If you have vector u and also vector v here, we can find this angle. Okay, using this formula. So, theta equal to inverse of cosine. Okay, just use your calculator. Okay, you must find u dot v here, and then divide by magnitude of u multiply with magnitude of v. Look at the example. Find the angle between the vector A and vector B. So find the dot product first here, because we want to find A dot B. A dot B equal to 2, 6 plus negative 2, negative 5 plus 1, 8. Okay, I just multiply the same component equal to 30. And then we find magnitude of u. U is V. A. Magnitude of A equal to, okay, how we calculate magnitude? We square the component. So 2 square plus negative 2 square plus 1 square. So we get negative 9 and square root 9, 3. And then we find magnitude of B. So we have 6 square, this one, 6 square plus negative 5 square plus 8 square. So equal to 125. And using your calculator, you can simplify it as 5 square root 5. So to find theta, inverse of 30 divided by 3 multiply with 5 and then simplify. You can leave it like that or you can use your calculator. Okay, and the last properties of dot product. Okay, if you calculate u dot v equal to 0, then u and v are orthogonal or perpendicular. If you calculate u dot v equal to 0, you get 0. Then u and v are actually orthogonal. So theta equal to 90 degree. Okay, look at this example. Determine whether the following vectors are orthogonal. Okay, to determine whether the vectors are orthogonal or not, you must find dot product. So A dot B, kita buat tadi lah. You just multiply the same component. 2 multiply with 1. 2 multiply with 1. Negative 2 multiply with 1. 2 multiply with 1. And 1 multiply with 0. So 2 minus 2 equal to 0. So since A dot B equal to 0, then vectors A and B are orthogonal. Okay, what about cross product? Dot product, you will get, when you dot vectors, you will get scalar. But if you cross, okay, you cross vectors, you will get vector. Okay, the final answer will be in the form of vector. So if we want to find U cross V, okay, first you put I, J, and K. And then you put the component for U. Because U, we cross U with V. So put U here. U below V. So we have U1, U2, and U3. Then you put V1, V2, and V3. So 2. Okay, next, you separate it. Okay, for the first part, first you remove this one, the I component. With this one, right? So write it here. And U2, U3, V2, and V3. This is for I. And then minus. Okay, minus J component. J, okay, remove J here. Okay, we have U1, U3, V1, and V3. Okay, and last one plus component for K. Ini pun sama, you just remove this component. And you write U1, U2, V1, and V2. Okay. Next, okay, to solve the determinant, you multiply this first, U2 with V3. Okay. This multiply this one and then you minus with this one. So you have U2 multiply with V3 minus U3 V2. Component for I. and then minus u1 v3 minus u3 v1 j plus 1 v2 minus u2 v1. So the final answer will be in the form of vector. Vector because we have I, J, also K. Then look at example. We do it together. Okay, let U. Okay, we have U and V here. Then find cross product of U and V. Okay, first, put the component for I, J, and also K. Okay, this one you put here. 2, negative 3, 1. And then V, negative 1, 3, 1. Then, what tadi lah. Write the I component minus J plus K. So for I component we have negative 3, 1, 3, 1. Okay, please do it together. We have 2, 1, negative 1, 1. 3, negative 1. And then multiply. So multiply here and minus. Negative 3, 1 minus 3, 1 I minus 2 minus 1 J plus 2, 3 minus 3. Okay. To simplify, you will get negative 6I minus 3J plus 3K. Or you can write it like this. Negative 6, negative 3, 3. Or you can write like this. Negative 6, negative 3, 3. We proceed to the properties of cross product. Okay, first, cross product is anti-cumulative. When you cross U, U cross V, it is not equal with V cross U. Okay? It is equal to negative V cross U. Okay, second properties. Okay, when you see cross and also plus, you must expand first. Okay, U cross with V plus U cross with W. Okay, the third properties. We can also find angle between vectors using cross product. So theta here, theta is the angle between U and V. It's the inverse of sine U cross V, and you find the magnitude. Okay, then divide by magnitude of U and magnitude of V. Okay, and last properties of cross product. Okay, two vectors are parallel if U cross V equal to 0. Okay, parallel. This U and this is V, parallel. Or they are scalar multiples of each other. Okay, look at this example. Determine whether the following vectors are parallel to each other. Okay, we have U and we have V. Okay, first you compare. You compare the vectors. You can see here, we divide we divide 8 by 4, you will get 2. Negative 12 divide by 4, you will get 3, negative 3. Yeah. So we have the same scalar here. So that's why U and V are parallel. Because U, we can write V. V equal to, vector V equal to 4 multiply with 2, negative 3. Okay, 2, negative 3 is vector U. So for U, vector U. If you can write like this, in the form of scalar multiplication, then they are parallel. Or you can compute the cross product. Okay, look at this example. We have A, vector A and also vector B. Okay. We know that if A cross B equal to 0, then they are parallel. So after I calculate A cross B, I get 0. Then A and B are parallel. Or you can compare the components. Okay, like example 1. Okay, I can see that vector of A here, is the scalar multiples of B. Okay, if you multiply with negative 2, if you multiply B with negative 2, we will get A. Okay, so A and B are parallel. Okay, so that's all for today.